is the Wednesday, the 25th. We're going to be continuing Unit 3, talking about absolute value graphs. We're going to be looking more at transformations, okay? But we started that talk last Wednesday here, okay? I was in a team planning meeting with all the Algebra 2 teachers. You were supposed to watch this video. The sub passed out the outline of the notes. So you can click here to watch that video if you didn't do it last week when you were supposed to. Or again, up here, if you click on notes, or over here in the navigation, if you click on modules, that takes you to the same place, okay? So when you come over here, here's our Unit 3 module, and it has all the blank outlines of notes, plus all the videos of the lessons. So this one from the 18th, last Wednesday, a week ago, was graphs and transformations of absolute value function. Okay, there's the video link, and there's the completed notes. So if what we do today is confusing, you don't remember this, that probably means you did not do this last week when you were supposed to. Okay, so you'll need to go back and watch that lesson and take those notes, and it'll start to make more sense. Okay, so the first thing I'm going to do is change the date because today is the 25th, not the 24th. Since I gave you time yesterday to finish the tests and do a little catch up, our notes dates are just going to be a day off because I had already printed all this. So let's change that to the 25th. All right. And again, we are talking about absolute value transformations. So before I even jump into these examples of writing equations with transformations given, real quick, what does the parent function of the absolute value function look like? Does anybody recall? Y equals, and then you have the absolute value bars around the F. That's the parent function for absolute value. Okay, now what we're talking about, again, this is the absolute value parent function up there. When we talk about transformations, what those notes last week went over, we're talking about, here's the equation with the possible transformation values in there. Okay, so this is what the equation looks like. And in those notes, we talked about what A, H, and K mean and how they affect your graph. Okay, again, if you don't remember that, go back and watch that lesson. Okay, you learned transformation rules back in previous math classes, but we did that lesson last week. You were supposed to watch that video and take your notes. So quick little reminder. First of all, the A value tells you whether or not the sign of the A value, I should say. So whether or not A is positive or negative tells you whether or not the graph opens up or down. If you have a negative A, your graph reflects over the x-axis. Okay. So the parent function for absolute value looks like this. Well, I shouldn't draw it that close to the equation. Sorry, I'll put it down here. It's the V shape. Okay, and that vertex is at the origin. Okay, that's the parent function, and that slope of the line, the sides of the line, this is a -1 slope coming to the origin and then a +1 slope. Okay, that's the parent function. So if A is negative, it reflects that graph upside down, meaning it's going to be opening downward instead of upward. Okay, so that's one thing that you should have taken away from those notes last week. She's here. And then the value of A, the number value, so that is in the parent function, what's here in front of the absolute value bar outside here. If no coefficient is written, what's understood? If no number is written, what number is here being multiplied? Come on, guys. If you just have X and there's no number in front of it, what's understood to be in front of it? A 1. Okay, so the same thing here. This A value is an understood 1 in the parent function. Okay, so if there is a number here other than 1, it's going to change the graph. Okay, so what that A value does is it's being multiplied by the absolute value function. And so it is going to be a vertical stretch or compression. When that A is greater than 1, okay, so if it's bigger than 1, you have a vertical stretch. Now, if that A is less than 1, but greater than 0, so we're not worried about the sign. The sign tells us if it's reflected or not, if it's opening up or down. But then the actual number, not worried about the sign. Okay, if it's a fraction or decimal between 0 or 1, that is a vertical, whoa. A vertical compression. Now, when we say stretch and compress, I think a lot of y'all can get a visual of that. What I like to imagine is putting my hands on top and bottom of the graph, like putting one hand on the vertex and one hand on the top here, and just stretching it apart vertically, because vertical means up and down. Okay, so if I put my hands on top and bottom and I stretch it apart, what's going to happen to the graph? What's it going to look like compared to the parent function? It'll look longer or skinnier, narrower. Okay. But if I compress it, if I have my hands on top and bottom and I compress, I squish it together, what's going to happen to the graph? Think about anything, not just a graph. If you're holding something and you pull it apart up and down, it gets skinnier, taller looking. But if you push it together, what happens? It gets shorter and wider looking, right? So I'm going to use those words narrower and wider here. So a stretch, a vertical stretch, makes the graph look more narrow. A vertical compression makes it look more wide. Okay, so that's how the A affects the graph. If it's negative, it's going to open down. If it's positive, it opens up. Okay, and then if it's any number other than 1, it's either going to look narrower or wider than the parent function. So instead of having that slope of -1, +1 on the two pieces, okay, it's either going to get steeper, okay, more narrow, okay, or it'll get wider, okay, less steep. Then the H and the K, if you recall, the H is the horizontal shift, and the K is the vertical shift. Now, when we say shift, that's translate, okay, slide. So a shift left or right, that's my horizontal, or a shift up or down, that's my vertical. Now, what we need to remember is that, I'll put H over here. This is the horizontal shift. Okay, now your horizontal shift, horizontal means left or right. The thing is, that negative, it is a minus H in the equation. The minus there is not part of the H. The H is just the number being subtracted. Okay, so your horizontal shift is actually going to be the opposite direction of what you initially think looking at the equation. Okay, so your H is positive. A positive H means that you're going to shift to the right. Okay, but in the equation, if I put in a positive h, that's going to be x minus positive h. Because the x minus is part of the equation. It's the h that's positive. So when you have a shift to the right, you actually see a minus in the equation. Now the reverse of that, if you have a negative h value, that would be a shift to the left. And if I talk about my equation, x minus, if I plug in a negative h, what happens when you have minus a negative? It becomes plus. So x minus negative h actually becomes x plus h. So that's what I mean when I say it's the opposite direction. And we talked more extensively about that in those notes last week. So in your equation, if you see a minus sign, that's actually a shift to the right. If you see a plus sign in your equation here inside, that's actually a shift to the left. Okay, so that's what I mean when I say it's the opposite of what you would think. Okay, now notice a horizontal shift was happening in here with the x because the x is the horizontal axis. Okay, now outside the absolute value function, the a and the k are outside. They are vertical changes because they're affecting the y. Okay, so a was a vertical stretch or compression. K is a vertical shift or translation. Now it's a plus sign in the equation, so it's going to be pretty straightforward. If you have a positive k, you're going to shift up. If you have minus k, if you have a negative k, you're going to shift down. Okay, so that's kind of, this is like sums up those notes from last week. So this is like your little refresher here. If that does not sound like a refresher to you, you need to go back and make sure you take those notes and watch that video lesson from last Wednesday. All right, so now let's use that information to write these equations. Okay, they tell us we're starting with the absolute value parent function, which is right here. So that's what we're starting with. And then a transformation is described, and we want to write the new function. So translated 9 units to the right, well, that is a horizontal shift. 9 units to the right, that means that's affecting that is my h value. Okay, so 9 units to the right means my h is positive 9. So in my equation, remember, it is x minus h. So when I plug in my h of 9, I actually get x minus 9 as the equation. Okay, so even though it went to the right in the equation, it looks like minus 9 because the minus is already in the equation. There was no other transformation, so A stays and understood 1. Okay, and there was no vertical shift, so nothing added on the outside. That's just a plus 0. Okay, so nothing written on the outside. So the only thing changed there was my horizontal shift. So that is the absolute value of x minus 9. Okay, now reflected across the x-axis, we said that that is our a value being negative. If we are reflected across the x-axis, a is negative. Now, it doesn't tell us it's stretched or compressed, so that means a is not something other than 1. It's still a 1, but now it's a negative 1, okay? So a is negative 1. So when I go to write my equation, y equals, okay, the a goes out in front. There's no horizontal shift, no vertical shift. I simply put the negative out here in front. I do not have to write 1. 1 is understood. I just write negative. So the negative absolute value of x. Okay, number 3, they have multiple transformations. They have reflected across the x-axis, so that tells me a is negative, and they have that it's translated 2 units to the left. So that's a horizontal shift. So we have that a is -1 again, and we have that h, left means negative, so left 2, so h is -2. But when I go to plug that into my equation, okay, I put the negative in front for the a, and then I plug in the h is -2. What did we say happens when you have minus a negative? It becomes a positive here. So that's going to become plus. So this is actually going to come out to be negative absolute value of x plus 2. So there are those transformed absolute value functions. Okay, number 4 says that there is a vertical stretch by 5. Okay, so that's our a value again, a vertical stretch or compression. That's our a. So a is 5. And we know it's, let's see, it's greater than 1. So it's a vertical stretch. A is greater than 1. Okay, and then it tells us we are translated to the right. So that's a horizontal shift, 3 units. And we are translated 4 units up. Okay, well, that's a vertical shift. So now I have a k change, a k value. So 3 units to the right means h is +3. And 4 units up means k is +4. So now when I go to plug those in, okay, so my a value, we said it's 5. My h value is 3. And my k value is 4. And I don't have minus a negative or anything that I need to change, so that's it. That's my absolute value function shifted 4 units up, 3 units right, and vertically stretched by 5. So far, so good? Specific questions right now? No specific questions? All right, I'm going to do 5 then. We're going to do the same highlighting and plugging into the equation. Okay, so vertically compressed, so that's A again. Compressed means A is less than 1, and they tell us it's 1/2. Okay, so I can mark here A is 1/2. Then it is reflected across the x-axis. Well, that tells us A is negative. Okay, so instead of just 1/2, what do I need to change that to? -1/2. Okay, so I'm going to change that here. Now that we read that second piece, it's -1/2. Okay, and then I'm going to go and the next one says it's translated 1 unit left. So horizontal shift, that's our h, and it's to the left, so h is -1. Okay, and then they tell us our vertical shift 7 units down. So that's our k, down is negative, so -7. So when I go to plug all of those in, have the outline of the equation, I'm going to plug in A, H, and K. So A is the coefficient in front. We said it's -1/2. H is the horizontal shift. We said it's -1. And K is the vertical shift. We said it's -7. Good. Now let's change those signs. Yeah, we've got some weird signage happening. We've got minus a negative. That becomes plus.
Good job.
And then what if about plus a negative? What could I change that to? Just minus, right? So I'm going to just clean that up some. That's going to be x plus 1 on the inside and -7 on the outside. Very good. Okay. So far, so good? Any specific questions on where we're plugging in the A, H, and K? All right, flip over. We're going to look at this chart on the back. So this is just a basic little chart. This is focusing on your A value. Shut up. So we already said on the front, that A value, filled out from last class. Don't look. Okay. We already said the A value, leading coefficient, that's our A value. We said that it's going to affect the graph by stretching it or compressing it. Okay, and we talked about the visual. Okay, if I put my hands on top and bottom of the graph and stretch it, it's going to look skinnier. If I compress it, it's going to look wider. Okay, so looking at these A values, so I've got an A of 3, 2/3, 3/4, and -4. Okay, I want to figure out which one is the widest and which one is the narrowest. Okay, so 3 and 4. Okay, those are the only whole number or integer values, right? These two are fractions. Okay, they're less than 1, aren't they? 2/3 and 3/4. So we know these two are going to get wider. And these two are going to get narrower. Okay. Which one is the widest and which one is the narrowest? So looking at the narrower ones, okay, we're talking 3 and 4. So if I'm stretching it times 3 or times 4, which one's going to be skinnier? Yeah, the bigger the number, the further away from 0, the more stretched it is, the narrower it's going to be. So even though that one's negative and that one's positive, we're not worried about the positive negative when we're talking about narrow versus wide. Okay, so the further away from 0 it is, so -4 is further away than +3, right? That is going to be the most narrow. So the narrowest graph is going to be this one. Okay, and then the widest is going to be the opposite. We said the further away from 0, the narrower it's going to be. The closer to 0, so the smaller the fraction, the wider it's going to be. So is 2/3 or 3/4 smaller? 2/3. 2/3 is closer to 0. So 2/3 is going to be the widest graph. Okay, so this is the widest. Okay, and this is the narrowest. However, if you have color, if you want to color code or mark it somehow, make sure you understand how we read that table. Now, up or down, what does that come from? What part of A tells us if it opens up or down? If it's negative or positive. Okay, so there's only one of those that has a negative A, this one. So that's going to open down. You can write down or you can draw a picture of it opening down. Okay, and then these 3 are all positive, so they're all going to open up. So you can write up or you can draw the picture of the absolute value graph opening up. Okay, so when A is positive, it opens up. When A is a negative, it opens down. When A is closer to 0, it gets wider. When A is further from 0, it gets narrower. Does that make sense? Again, if you're struggling with today's lesson, if you're like, I am thrown off, I don't remember this, probably didn't do what you're supposed to last week. Okay. Now, if you did watch that lesson and take those notes and you're still confused, okay, ask questions as you're doing the practice today. Sign up for Cat Tracks, come and we can work more one-on-one, get some additional explanation in there. Okay, but if you haven't even done the lesson from last week yet, that's what you need to go to first. Good? Okay, so then I'm gonna pull up. We're going to do practice in Delta Math, but I just want to point out in the Delta Math, there is only one under the upcoming. Okay, again, sorry, I was at the board. Let me put this on here for those watching the recording. We said the leading coefficient that's talking about A, when A is negative, it opens down. When it's positive, it opens up. And then we said the further away A is from 0, the narrower the graph is going to be. So 3 and 4 are both greater than 1. They're both going to make the graph narrower. Okay, but 4 is the furthest. So the narrowest graph is this one. Okay, and then we said the closer to 0 you are. So looking at these that get closer to 0, they're fractional values. They're less than 1. The closer to 0 you are, the wider the graph is going to get. And 2/3 we said was closer to 0 than 3/4. So that was the widest graph. Okay. So now you should be looking in Delta Math here. Oh, and also Desmos. You can always use Desmos as a check. Okay. So if you weren't sure, like if you're like, I kind of struggle with fractions. Was it that 2/3 or 3/4 that's smaller? Okay. Look, I just plugged them both in and looked at them. Okay. The 2/3 is the red graph. The 3/4 is the blue graph. The blue one is narrower. Okay. The red one is wider. Okay. So the red one, 2/3, is the widest graph. If you needed to look at all 4 of those together, you could have done that. I think it was 3 absolute value of x and -4 absolute value of x. So you could look at all of those, all 4 of those graphs together. You can see that one opens down, okay? But see how the green and that purple definitely are narrower if you need to turn off the wider ones to focus. And if you can't tell because one's positive and one's negative, just take the negative off so you can see them side by side. And now you can see the purple one is more narrow, the one that had the 4, because 4 is further away from 0. Okay, so you can always look in Desmos to get a visual of those graphs if you need to. Okay, now in Delta Math, my subscription needs to be renewed. You've got one upcoming assignment, that's today, okay, practicing what we just talked about. It's due the 29th, because today's Wednesday, so it would fall on Friday, so I give you the weekend. So you've got all the rest of this week and the weekend, Sunday night, 11:59 p.m. to get this one done. Okay, there were 2 from last week, the 18th and the 19th assignments from Unit 3. Those were both due last night for full credit. If you started those and got some of it done, you can still come in here and finish, and you're only getting the late points, the 75% credit on what you do late. So if you did part of it on time, you'll get full credit for what you did on time. Okay, anything that shows up under no credit available, you can still look at, but you're not going to change your grade. Okay, that no credit available, if you have anything under there past due, that's from unit 1 or 2. Okay, we're moved on to unit 3. Okay, so these from last week, unit 3 assignments, you can still get 75% credit, and that's through tomorrow, and then they'll drop to 50% credit. Okay, until we test. Okay, and then let me just refresh you on the calendar for when that test is. I know we looked at this at the beginning of class, but here we are. This is today. That test is next Thursday. Now that test is going to be not just a unit 3 test, but a 9 weeks test. So it'll be more unit 3 heavy than the unit 1 and 2, but there will be unit 1 and 2 content on here as well, spiraled back in. Okay, so that is our 9-week test that will cover majority unit 3, but still some unit 1, 2 mixed in there. Okay, and that is a week from tomorrow. So just keep that in mind. Yeah. Okay, you all have time to work. You can work with partners, use those notes. If you need to go back and watch that lesson from last Wednesday because you hadn't yet, you can do that. If you've got headphones and you want to go watch that right now, instead of working on the Delta math, that's fine too.